Hey, Alex Barrel here. Welcome back to the Wireless N64 controller series. In this episode, we'll be taking a look at the software tools and getting a sample project up and running. And then we'll take a closer look at the N64 controller. Let's go. Nordic has what they call this Dev Academy, which is a series of courses designed to help developers get up and running with their software tools and concepts. So they have this one called NRF Connect SDK Fundamentals. And if we go in here, we will find the instructions on how to install the various software tools. So number one is Seger J-Link debug tool, and has drivers for talking to the NRF54L15DK that we have here. VS Code is going to be our IDE, so we can edit code, and through some additional tools we'll be able to flash and debug the part as well. Third, we need to install the NRF Connect extension pack, which is a tool that lives in VS Code to let us build and debug. And then fourth, we need to install the SDK. The SDK is a software development kit, and it contains drivers for different peripherals and functions. So developers don't need to know all the low-level concepts of different peripherals and their interactions to be able to get up and running with something very quickly. Just a quick note, there are two versions of the SDK. One is called NRF Connect SDK, which relies on this operating system called Zephyr. And there's another version called NRF Connect SDK Bare Metal, which skips out on the operating system and gives the user a little bit more control at the low level. We're going to use the NRF Connect SDK Bare Metal, but to be honest, I'm not sure how much of the SDK I will actually be using. I kind of prefer to use peripherals directly. Okay, so I've gotten everything installed per the Nordic's instructions, and this is what we're working with here. Here's our VS Code window. And over on the left here, we've got our various tabs for different things. This is the NRF Connect tab, and this is where we're going to find how to get sample projects or start new applications. So we're going to go with create a new application, and we're going to copy a sample. And it lists all of the samples that are inside this NRF Connect SDK applications. So all the ones that say NRF-BM, those are the bare metal ones, and we're going to start with one of those. So the LEDs, and we're gonna say NRF LEDs. Oops. So this is our folder that we're looking in. Okay, press OK. Create the new application. All right, now we've got our source code here. And we don't need to worry about what this does yet, but down here is our LED logic. So we turn the LED on, which writes this GPIO pin. We wait for 500 times some constant. It'll be 500 milliseconds essentially, and then turn the LED off, wait for another 500 milliseconds. Okay, but as you can see, there's a bunch of red scribbles. So we need to build for this, for the software to be able to kind of find all of these include and config files. So we're going to go back to this one. Now here's our application here, and we need to add a build configuration. This will pop open this build configuration window, and we can choose our board target so we know what device we're working with. And these are what the SDK, the bare metal SDK sees as the compatible options. We have the NRF54L15 on our DK, so we're going to use this one. And then we can leave everything else blank. It'll automatically select what it needs. Okay, we'll generate and build. So this generates the include files that we need, plus it builds it. So then all that's left to do for us is to flash it to our part. Okay, so we successfully built without any issues, and now you can see that all of these red squiggles are gone. So the configuration has found all of these include files. And now we can see some of these constants. Okay, we've got this action flash. No devices connected. Let's pop over to our SDK and we'll turn it on. Okay, so here's our board. We'll turn it on. And we can see one of the LEDs is blinking. I've already played around with this board a little bit, so I've changed which LED it is. In here, the software says it's LED 0. So now let's go ahead and see if we can flash the part. Programming. Okay. So now I've got LED 0 is blinking at what we can assume is 500 milliseconds. Let's go back in here and we'll change some of the settings. So let's change this to 1000. And this should make it on for 1 second and off for 1 second. And let's build it. Then we'll flash it. Okay, and the LED looks to be flashing slower. Let's see if we can change which LED it is. Let's go LED 3, which is this. It's LED 0, 1, 2, 3. So it'll be this bottom corner one right there. And I found a mistake. We did not do the LED init board pin LED 3. We only changed the LED on and off. Okay, let's try again. Okay. So LED 3 is blinking. 1 second on, 1 second off. Great. Okay, we're going to introduce a new tool called the Logic Analyzer. Here it is, here next to the development kit. And what it allows us to do is to see electrical signals. In this case, we're going to be looking at their digital transition, so whether a signal is high or low. We're going to look at the LEDs, and for this one, it's not going to be very exciting. What we'd expect is the signal to be high for 1 second, and then low for 1 second, and so on and so forth. But where it gets more exciting is when we start looking at the N64 controller, and there's more variety to the signal. So how do we connect to the LEDs with this logic analyzer? First, we can pop open the development kit user guide, which has sections for each of the various elements that are included on the board. So under the buttons and LEDs section, we can find that the various buttons and LEDs are mapped to these specific GPIO, which is general purpose input and output pins. Our LED 3 is mapped to P1.14. And what exactly does that mean? Well, if we look over here on the board, we can see that we have port 0, port 1, and port 2. And next to each of these pins is a little silk screen with the corresponding name on it. So right here we've got ground, and right next to that ground pin is a 14. So this is port 1, pin 14. So with our logic analyzer, we need to connect ground and signal. So let's go ahead and connect the ground. There. And then our pin 14 signal. There. Okay. Now let's pop open to our logic analyzer software and we'll take a look. So as we expected, high and low in even amounts. And if we take a look at the timing, we can see that we're high for 1 second and 3.3 milliseconds and low for about the same time. And it's pretty consistent. So this pattern would just repeat. Okay, so we're going to switch gears and we're going to show the logic analyzer with the N64. So here I've prepared the controller with a little connector, a 3-pin connector that's got, these are the only 3 cables on the controller, power, ground, and data. So we will plug that in here. And then the console, similar matching cable here. We'll plug that in right there. And then our logic analyzer, 1 pin connected to ground, which is the bottom pin here. And then the other pin connected to the signal in the middle. And we've got a couple of games here. The first one is Super Smash Brothers. I noticed in the original project that different games have different polling rates or different combinations of commands that they send to the controller, so we're going to take a look at 2 of them here. So the first being Super Smash Brothers, and then the second one, my very first game, Pokemon Snap. Okay, our logic analyzer is ready. So we're going to start the analyzer, and then we'll start the N64. Okay, so I've got a couple of captures here. So let's zoom in on one of these, and we'll see what this kind of looks like here. So a stream of bits, and we don't really know, up until this point in the video, we don't really know what this means yet. So here, we're going to take a look at an analyzer. So just a side note, throughout this project, I am literally standing on the shoulders of giants, those who came before me. I found this custom logic analyzer that was made by a fellow named Jeff Longo on GitHub. It was made for the Gamecube controller, but with the help of Claude AI, I adapted it for the N64's commands, since the protocols are almost the same. So let me do this again. So now we're kind of capturing more like a triggered view like we would with an oscilloscope. So I'm going to show you what the buttons, so I'm going to start pressing some buttons, and then we can see what happens in the signal. And you can see that these sort of correspond to different button presses, and the analog stick on the back here. All right, let's give that a stop. So with our analyzer here, we can see what the conditions are of various button presses. A, B, Z, R. So those correspond to these bits here. So the work of the protocol decoding has actually already been done here on this n64brew.dev under the JoyBus protocol page. So a couple of pretty helpful things that we can glean from this are the bit timing, what logical 0 and 1 and stop bits look like. Number 2 is the command list. Of most important to us is the controller state, but I've also seen the info command on the logic analyzer. And then finally, the standard controller state, what the buttons map to. So this is the full 32-bit response, and each corresponding button and which bits each corresponding button has on the controller. So if we jump over to look at what we have here, over on the left we've got our 8-bit command, followed by the controller stop bit here, and then from here to here is our response. And as you can see, the logical 0, it's low for 3 microseconds and then high for 1. And the logical 1 is low for 1 microsecond and high for 3. So my guess is that around the 2 microsecond point is probably when the console is sampling to see what is the logical state. So then if we look over here, this is just a random controller read that I grabbed when I was pressing buttons and doing the joystick. So you can see that like we've got A pressed, and we do it in red here. A, B, Z is pressed, the right trigger is pressed, and then on the X and the Y axis, So this is really helpful for us because we don't need to go and decode all of these buttons ourselves. We can kind of rely on what others have done for us. So essentially the project all boils down to this. How do we get our module that's connected to the controller to generate the command to get the buttons and then read the button response and send over to the console connected module? And then on the console side, how can we get the console to read the command and interpret whether it's info or controller status or something else, and then generate the appropriate response? That's the entire project in a nutshell. And in the next video, we're going to explore how we're going to do that by digging into the datasheet and the peripherals. Stay tuned.